Well, like most chapters, chapter 10 has a really good Excel file that comes along with it that I've got available. All these are available in handouts along with the PowerPoints. And this walks you through the example that the book gives you. The book gives you an example called Allied Foods, which they've been using throughout the chapters, and the PowerPoints always pick a different company. So it's kind of good in that you get two different examples to follow, the PowerPoint example and the book example. And then again, this Excel is just right from the book. The book uses some pictures of this Excel as they go through and walk you through the Allied Foods example. And they're going to just kind of walk you through this. And what's nice about these is you get to see the formulas. And so down here they're just basically saying that the cost of debt was 10%, tax rate's 40%. So basically my cost of debt is 6% after we adjust for tax. And then they got the preferred stock example down here. Right here, preferred dividend is 10. We divide that by the price of my preferred stock and we get the cost of preferred stock, which is 10.3. Then they talk about the cost of retained earnings. Remember, there's three different examples to compute the cost of retained earnings. The CAPM approach is the first one they're showing us. That's the capital asset pricing model. And the formula is right there. And I know this is kind of small to see. I've even got my Excel up to 125%, but I know that's kind of small. But you can see here what the formula is. And what we're doing is we are risk adjusting a stock basically by using the beta for that stock. And the beta for the example here was 1.48. So the risk-free rate for this company was, or the risk-free rate in this example is 5.6%. The market risk premium for this company is 5%. And so what we do is, by using the CAPM formula right up here, basically the risk-free rate plus the RPM times the beta gives us the cost of retained earnings of 13. So that's, the beta is for this company. Okay, and it says, we could do this example here with Excel of computing different rates of return based on different betas if we wanted to. Another approach is to do what they call the bond yield risk premium approach. And so we're basically just looking at our bond yield and then adjusting that for risk, and then it's basically approximating that to a cost of retained earnings. So bond yield is 10, equity risk premium is 4, minimum is 3, maximum is 5. And so we're kind of just coming along with an estimate here between 13, 14, and 15. And we're saying you probably just go with the 14 as a good approximation. Discounted cash flow, DCF, or dividend cash flow. I like to think of it as dividend cash flow when we're looking at dividends, but when we're not looking at dividends, we can call it discounted cash flow. And suppose the firm's stock trades at 23.06. Its expected dividend is 125. Expected growth is 8.3. What is the cost of equity? So 23.06, 125, and 8.3. And then what we can do is compute my formula right there. So it's going to take those numbers right there. So basically D1 divided by P0 plus the growth rate. Okay, so D1 is 125 divided by the price of 23.06 plus 8.3 is my growth rate. And that gives me my answer of 13.7. And so just like we did in the PowerPoint, this example looks at all three of these basically just averages them out and says the midpoint is 13.5. Okay, so we can use that as basically the cost of retained earnings. Now, if we're going to issue new stock, we can use the cost of new common stock. And then typically we do factor in flotation cost because quite often when we issue stock, there's a flotation cost. Even the very largest of stock issues have flotation cost. Maybe only 5 or 6%, but they still have a flotation cost that is significant enough that we have to include it. So the price is 23.06, dividend 125, growth is 8.3. Now we're really just factoring in the one new thing, and that is the flotation cost. That's really the only difference between what we did up here versus what we're doing down here. So we just added the F component. And so you can see that the new stock offering, that cost, the formula is right there. And then the cost of retained earnings is just simply what we did up above right here. And the difference is 0.6%. So there's an extra cost of 0.6% to issue stock. So the flotation adjustment is 0.6, And so if we're going to issue new stock, that cost of equity would be 14.1. Okay, so that was the meat and potatoes of what I wanted to show you there. I'm skipping the retained earnings breakpoint, by the way. I'm skipping that on purpose. And then just getting down to our composite weighted average cost of capital down here. You can just see how we came up with that. Just you can look at this formula here, and you can just see that they added, basically did the full calculation now with the formula and added up the three components of the calculation. Okay, so basically, what's the cost of capital if we used our retained earnings, 10.1, or if we issued new stock, which would be 10.4, a little bit higher. Okay, and then what these Excels always do is gives you the illustrations used in the chapters. This table was in the chapter, and then the various self-test questions that are embedded within the chapter. The answers are always just right in here. So, what these are really nice for is that you can, use these to compute things. So, the rate formula is right here. And remember that the Excel file I gave everybody to use in the present value, future value chapter has the same rate formula in it. It's the exact same setup as this. There's no difference between them. And so if you are asked to compute a rate of return, just like we were in the PowerPoint that I went through with the chapter, you can use this file, or you can go back and use the Excel file from the present value, future value chapter. But this is just really nice examples for you to follow. And then here's the file to compute, or I should say the formula to compute the price of dividends again, or the cost of dividends, I should say. And then again, they're giving you more examples to compute the cost of equity for retained earnings using the various approaches. So just more examples to follow. And these are good examples to follow when you're doing the work in Aplia, because you can just, in Aplia, when you're asked to compute things just exactly like this, you can come over here and just plug in these formulas and just plug in your new numbers, and the formulas are already set up for you to use. That's a really good approach to doing these. So the examples in the book versus just using this Excel file to do your Aplia work. And you can't break these Excels. If you mess up a formula or just overtype something you didn't mean to, just go open up a new one. That's all you have to do. So you've always got a fresh copy of it over in our class in my.usf to go and grab if you accidentally mess one of these up. So don't worry about doing that. You can't break these Excels. But they're great examples to follow when you do the work in Aplia. As always, if you have questions about this, just let me